is there to communicate. If you just put 1/seconds, it is technically not wrong. If you put hertz, it is wrong. All right. So what's the regular frequency? Sorry to spoil the opportunity for you to tell me what the symbol for frequency was. Or it is.
It's 1/2500 angular frequency.
Yeah. Right there. So this becomes 2.23 radians per second divided by 2 pi, technically radians. And so what do we get for the frequency? This seems like it should be somewhere around 0.35. You had 3.50?
Yeah.
Yeah.
Oh, did you do 2.1 on your calculator? You typed in 2.23 divided by 2 pi?
Yes.
Did you put the parentheses in?
Negative.
Because it multiplied by pi. You divided by 2 and then multiplied by pi.
Oh, yeah.
3549.
0.3549? All right, units?
Is this one gonna be hertz?
Hertz.
Yeah, hertz is appropriate, or 1/seconds also works, but let's go with hertz. Because of course we're cool.
Cool like it.
All right, so what we're claiming here is that every second that passes by, it has done a little over 1/3 of a cycle. A cycle being from where it starts, all the way back to where it starts again. So if my frequency is 0.3549 hertz, how long does it actually take to do the full cycle? In other words, what is the period? Or what is the formula? How would I find it? For those without calculators.
Then 1/the frequency.
It is. So what do you get?
We got 2.82.
Okay. I knew it was somewhere around 2.82.
Yes.
That confirmation?
Yep.
All right, units?
Seconds.
I hope so. We are talking about time, and we've been dealing with SI units all along. All right, so I now know how long it is going to take to do a full cycle. Without a calculator, for this next bit, without a calculator, when time equals 1.41 seconds, what is the position?
It's like halfway, isn't it?
Which means
Uh,
you're correct, but depends by halfway between of what?
half an oscillation.
Okay, so where does that put it? Don't assume that Brandon is going to help all the rest of you out. Where is it? He's right, it is halfway through an oscillation, absolutely. Spot on.
Like 3.5 meters.
That's what I was hoping, not I was hoping you wouldn't take it there,
Okay.
because I think most people, when you say halfway, you're thinking, well, it goes out to 7, so halfway, no. Halfway of an oscillation. The halfway point in the oscillation is here. That apparently didn't mean much to you.
No, I'm sorry.
Well, let's plug and chug. You know what? We have omega, we have A. Phi is 0, because we started the time when we were at the maximum. So my position formula is 7 meters times the cosine of 2.23 radians per second times 1.41 seconds. Don't forget, we are working in radians here. What'd you get, Greg?
I got 9.8 meters.
Whoa. Yeah, something went off there.
-7 meters.
-7 meters. Not quite sure where you typed something in there, Greg.
I got it.
Yeah. So halfway through, so we start out with this thing at 7 meters. It's gonna compress down to -7 meters and then back to 7 meters. So halfway in the trip, it's at -7 meters. So close. What about at 0.705 seconds? Where is it gonna be? Now, there's gonna be some rounding issues in there, but hopefully you get close enough. .705 seconds, where is it? So I did the math right now, so I'm good on that.
So, is that 6.997?
Oh, that -7 there?
Oh, yeah, that's what
Oh, when did you get that number you just said?
did I put this?
Oh, you put in .705, so it should have been 7 times the cosine of 2.23 times. So it should be 2.23 times .705. And then the cosine of that, then times 7. So it looks like that's what you typed in. Are you in radians? All right, so just popped it in there and you got -0.04. And so there's a rounding thing in there. Where does that put it? So plugging straight in, assuming that I think she typed it in correctly. Anyone else get -0.04? What'd you get, Amy?
I got -0.009.
-0.009, okay. -0.009?
Yep.
So, I suspect it's a rounding issue, but recognize what I asked here. So so it starts here. It takes 2.8 seconds to get all the way back to here. 1.41 seconds was when it was over on this extreme. And now I've asked for half that. I just did half. The 0.705 comes from half of that. So at 0, it's out here. At 1.41 seconds, it's at the other extreme. So where is it halfway in between? At 0.705 seconds, it should be at equilibrium. which is 0. So that's why I was expecting 0.0 something, so 0.04 potentially, or 0.009, which is an even better value, or if you hit 0 exactly, that'd be even better. There was one test where I actually did that, where I set it up, and then I did it, where is it at half the period, where is it at a quarter of the period? And most of the students had the formula, so they started plugging into the formula, and then those who didn't set their calculators into radians missed it. Or you could just think through it. So x of point, well, in essence, the period divided by 4. 0. I guess we're just using plus and minus. We don't necessarily have to have that there. All right, maximum speed. Let's see, I'm gonna need some room here. Omega equals frequency equals square root of 5 over 2 pi, which equals 0.3. Starting conditions, good enough. I'm gonna leave the picture there. All right, that should be enough room. Vmax. Maximum speed. Where is the speed to maximum? Or what is it? How would you find it, given what we know?
Max displacement times angular frequency.
Say it one more time.
Maximum displacement, or the amplitude times angular frequency.
Yeah, right there. The amplitude is the maximum value for a cosine and sine curve. So it's just a times omega, which is, my amplitude was 7, and omega was square root of 5. So technically it's square root of 5 radians per second and 7 meters. And please don't leave the answer like that.
15.65. meters per second.
What happened to the radians?
They didn't feel like showing up.
Okay. Wait, that better. If you put meter radians per second, it's not necessarily wrong. Just if you write meter radians, make sure there's a dot between the M and the rad. Otherwise, it's milliradians per second, which is not right. And my maximum acceleration? Go for it. Somebody just.
Isn't that just 35?
Pardon?
Isn't that just 35? Because that's 7 and stuff?
Yes, it would be. A omega squared. Which is 7 times square root of 5 squared, which is 35. 35 what?
Meters per second squared?
I hope so. Otherwise, it's all been a lie. All right, so finding the maximum velocity, maximum speed, I did ask for speed there. If I said maximum acceleration, I should specify whether I want the vector or the scalar. But generally, when you're talking about a maximum, that's what you're going for. You're going for the scalar. And the speed is maximal when it's at equilibrium. So what I want to do is I want to solve for these two things a very different way. I mean, ultimately it all ties together, so it's not like we're coming up with a brand new set of math here. But there is another way of finding the maximum speed and the maximum acceleration. And so at this point, those who are taking notes, we have the in your notes already. It's going fast. All right. So in the situation here, I want to basically look at it from an energy point of view. We have three forces acting on the mass once I let go. So when it is here, what are the three forces acting on the mass? Should I start out with force diagram? What are the three forces acting on the mass?
You have tension from the spring, correct?
Right. I'm going to call that F sub E for, no, sorry, F sub S for the spring force. It is a tension, but we have, tension as a general rule doesn't have a separate formula, but spring force does. So I'm going to keep it at spring force.
All right.
And
Weight.
yep.
And normal force.
Yep. So, which of these forces are doing any work?
Could be friction?
Frictionless surface.
Oh,
You want to add friction into it?
no,
Okay.
that's okay.
At that point, it becomes damped harmonic oscillation. I was hoping to avoid it, but we could do it.
It's all right,
Thank you for your flexibility.
anytime.
All right, so which of these are doing work? We got these three forces here.
F of S.
All right, why are normal force and weight not doing any work? They lazy bums?
Yeah.
What's a physics explanation for why they're not doing any work?
I have a question first.
Okay.
So what is F of S? Because I mistakenly called that friction. That's what I
okay.
intended when I said that, but.
The difference in the way I write it is that if this were friction, I would have gone for the curled F like that, same symbol I use for frequency, and then that would be static friction. And that would be kinetic friction.
Because that's what I thought that. Okay.
Yeah, at some point it crossed my mind and then it quickly went away, so. Now this is a capital F, to try to differentiate it from my friction force.
Okay,
Okay, so which one's doing work? Then this one.
yeah.
That's what you're going for,
that's what I
okay.
meant, yeah.
All right, so then the other question, Jen, is why are these not doing any work?
They're not like moving in that direction, then.
Yeah, pretty much. They're perpendicular. I think that's what your hand gesture was indicating.
Yeah.
Yeah, it's moving this way, but those forces are vertical while it's moving horizontally, so that, yeah, they don't do any work there. All right, so is the spring force conservative or non-conservative? It's a 50-50 shot,
I say conservative.
and that of the two choices, that was probably the better one. It is a conservative force, which means what? Why are they called, why are forces Why would a force be called conservative?
We end with the same energy we start with.
Yeah, it conserves energy, that's why it's called conservative. So we have energy conservation. E initial equals E final. I have two types of two types of energy, kinetic plus potential is equal to kinetic final plus potential final. Prepare yourselves mentally, because you know the question I'm about to ask here. In unison, with great enthusiasm. Well, that little extra bit to it. Ready, Brandon?
I'm preparing, yeah.
Okay, sorry, I didn't want to cut your preparation
No,
short, did I?
Again, flexibility.
All right. What's the formula for kinetic energy? You leaving Amy out there hanging? Let's try that one again. What's the formula for kinetic energy?
One half times mc squared.
I'm not sure, the great enthusiasm piece was there, and there were some voices I didn't hear, but I'm gonna have to settle for that for now. So, what about 1/2 I omega squared? Should we throw that up here too? When do you use 1/2 I omega squared? What is 1/2 I omega squared?
Rotational kinetic energy.
Okay, so does that apply here? Why not?
Because it's not rotating.
Yeah, or rolling, any of that stuff. All right, so potential energy, not gonna ask for unison on this one, but what's the proper response if I say, what's the formula for potential energy?
Which one?
All right. Felt like that was more in unison than the first time I asked the other one. So our